In this section, we're going to be looking at 5.4, which is more trigonometric graphs. So in the last section, we looked at sine and cosine and graphed those. We're going to look at tangent, cotangent, and secant, cosecant today. So for the tangent and cotangent curves, the functions y equals a tangent of kx and y equals a cotangent of kx, with again k is greater than 0, these have period pi over k. Here's an example of the y equals tangent of x graph. We have vertical asymptotes here at negative pi over 2 and positive pi over 2. And the graph goes through the center 0, 0, or the origin. Okay, so let's use that as a baseline, and let's attempt to graph a tangent equation based off of that. So here we want to find the period of y equals tangent of 2 times x minus pi over 6, and then graph this function. Okay, so to do that, the first thing I want to do is find that period. So the period is equal to pi over k, which is pi over, here the k is the thing multiplied on the inside of the tangent function. So we got 2 times all of this, so it's pi over 2 is our period. And so let's draw this. Normally, we start at the origin, 0, 0. But this phase shift here says, right, we have x minus pi over 6. That means we move the function to the right by pi over 6 units. So if I move over to the right, pi over 6, and I will plot a point there. Now, our function looks like this one above, but what do we want to do? Well, we want to find the period which we have as pi over 2. Well, that period goes from all the way over here on the left, where we have a vertical asymptote, all the way over to the right, we have the next vertical asymptote. So where are vertical asymptotes for this function here? Well, if the period is pi over 2, that says that half of that is on the left and half of that is on the right. So we need half of that, which is pi over 4 to the left, and half of that, which is pi over 4 to the right. So to find out where that's actually plotted at, we'll do pi over 6 minus pi over 4. Okay, to add these, or subtract these in this case, this would be 2 pi over 12 minus 3 pi over 12, which is equal to negative pi over 12. So our vertical asymptote is at negative pi over 12. And our next vertical asymptote would be pi over 6 plus pi over 4, which is equal to 2 pi over 12 plus 3 pi over 12, which is equal to 5 pi over 12. So the right side vertical asymptote is 5 pi over 12. And then we draw in our tangent function. And that's it for this example. We'll move on and do an example related to cosecant and secant. But the first thing I want to do is just talk about those functions. So the function y equals a times cosecant of kx, and the function y equals a times secant of kx, where again k is greater than 0. These have period 2 pi over k, so it's the same formula for cosine and sine. I've drawn an example of the y equals cosecant of x function here. Again, the standard is 2 pi over k. If k is 1, then the period is 2 pi. So we start at 0, and we go all the way to 2 pi for the period. On the first half, we get this U shape that is faced upward. And on the second half, we get a U shape that is facing downward. So let's use that information to do example 2 here. So example 2 asks us to find the period of y equals 3 times cosecant of pi x minus pi over 3, and then graph this function. Well, to do this, we need the function to look like y equals a cosecant of k times x minus b, right? We have a phase shift here, so we want it to look like this. So we need to factor out our k. Well, what's in both pi x and negative pi over 3? Well, pi is in both of those, so we can factor out a pi out of this. So our function is really y equals 3 times cosecant of pi times x minus 1/3. So this tells us that k is equal to pi, and the phase shift b is 1/3. So what does that tell us? Well, that tells us our period is 2 pi over k. So that is 2 pi over pi. So that tells us the period is 2. And the phase shift is 1/3, so it means we move everything over to the right 1/3. This positive 3 on the outside, we're multiplying that. That's a, if you recall, that is a vertical stretch. So it's just going to make the U that's facing up and the U facing down a little bit more narrow. But when we draw it, it's going to look all the same. So we have 1 and negative 1 as our starting values here. And like we've said, we move over to the right 1/3 unit. So normally our vertical asymptote starts at x equals 0. Here it's going to start at x equals 1/3. And our period is 2. So if we add 2 to 1/3, we get 7/3. So our function will end, or our one period will end at 7/3. And halfway between that would be 4/3. And again, the first half is a U facing upward, and the bottom half is a U facing downward. And that concludes the drawing of y equals 3 times cosecant of pi x minus pi over 3.